Okay, so welcome to the second video for 8.3. So let's first recall that if I have cosine of theta plus 2 pi times any integer k, this is the same as cosine of theta because if I go full circle, so for all integers k, if I go 2 pi, which is full circle, I come right back to where I am on the unit circle. And the same holds true for sine. So sine of an angle theta plus any integer multiple of a full revolution, that is 2 pi, is just sine of theta, right? Because I've gone full circle on the unit circle, I've come right back to where I am. Okay, so let's consider z being equal to the square root of r times a quantity cosine of, let's do theta divided by 2, plus, to force the 2 pi, let's do 2 pi divided by 2, plus I times sine of theta over 2, plus 2 pi divided by 2. So why am I doing this? Well, let's see what happens if I evaluate z squared. So this would be quantity, the square root of r squared, times the quantity cosine of 2 times the angle, which is theta over 2, plus 2 pi over 2, plus I times sine of twice the angle, which is theta over 2 plus 2 pi over 2. Okay, so what do we get? So the square root of something squared is just what's inside, so we just get r. And this will become cosine of distributing the 2 inside. The 2's in the denominators reduce. So I'm left with cosine of theta plus 2 pi plus I times sine of theta plus 2 pi. But I know that any integer multiple of 2 pi is the same as the original function. So this is r, the modulus, times cosine of theta plus I times sine of theta. Okay, but what does this really tell us? Well, let's consider z equals to, note, if we have now z being equal to the nth root, let me move this a bit to the left. So for z being equals to the nth root of r times a quantity cosine of theta over n plus 2 pi over n plus I times sine of that same ugly argument, theta over n, plus 2 pi over n. What happens when we raise z to the nth power? Well, what we get is quantity, the nth root of r to the n, times cosine of n times the quantity theta over n plus 2 pi over n inside the argument, plus I times sine of n times the quantity theta over n plus 2 pi over n. All of that inside the argument of sine. Okay, so now I'm going to distribute the n to both terms inside each of the trigonometric arguments. So z to the n. Well, the nth root of r to the n is just r. And when we distribute, we will have cosine. The n's are going to reduce. Quantity theta plus 2 pi. Interesting. Plus I times sine of theta plus 2 pi. But remember, any integer multiple of 2 pi reduces. So this is simply r times cosine of theta plus I times sine of theta. Okay, so what we have is the nth roots theorem, plural. So the nth roots, plural, theorem, because this is just more than what I've shown above, but hopefully that'll be a good starting point. So let's let z be r times the quantity cosine of theta plus I times sine of theta. Be a complex number. Let's have n be a positive integer and r some real number. It's a modulus. Then how do I want to say this? The kth nth root is given by so the nth root of z sub k will be the nth root of r. So what do I mean by that? K times cosine of the quantity theta over n plus 2 pi over n times k plus I sine of the same argument, theta over n plus 2 pi over n times k, where k is 1, 2, 3, all the way up to n minus 1. Oh, did I fit it? I almost fit it on one page. Okay, thank goodness. Okay, so this is going to be a bit crazy. So each time we take a fifth root, say, there has to be 5 roots. If I take a cube root, there has to be 3 roots, etc. So that's what we mean by the k's. So for example, so let's find the complex nth roots for the following. So find the n complex nth roots for the following. And actually, because it's n, k starts at 0. Let me first put 0 here. 0, because there has to be n roots there. Okay. Okay, so number 1, let's say we have cube roots, the 3 cube roots of z being equal to the number 27. Okay, so you might say, well, the cube root of 27 is 3, and that's true. That's just one of the 3 cube roots. So we have z is 27. So I'm going to write this as 27 times the quantity 1 plus 0 times I, because there's no I there. But when I write it this way, cosine of what is 1 and sine of what is 0? Well, that would be cosine of 2 pi, or 0, plus I times sine of 2 pi, or 0. Might be easier to write it as 0, so let's do that. That'll make our lives easy to start with. So cosine of 0 radians plus I times sine of 0 radians. Okay, so first we want to find z sub 0. So z, how do I want to say this? The cube root, so z sub 0 the first cube root is going to be the cubed root of 27. But now what we're going to do, we're going to have cosine of 0 over n. So what is n in this case? The n is cube root, so the n is 3. So actually let me do that in orange. Cube roots. So n is 3. So we have 0 over n plus 2 pi over n times k. Well, what is the subscript for this one? 0 for this subscript. 0 plus I times sine of 0 over n plus 2 pi over n times 0. And our n, oh shoot, what did I write? N, it's 3. What am I saying? It's 3. Because that's what n is for this problem. And this is our first root, so we always start k at 0. Okay, so what do we get here? The cube root of 27 is 3. Okay. And what we end up with is cosine of 0 plus I times sine of 0. Okay, so that's just 3, right? Because, after all, maybe I'll skip the line. This is just 3 times 1 plus 0 times I, which is just 3, as it should be, because one of the cube roots of 27 is indeed 3. So we knew that already. So now let's find the other roots that aren't so obvious. And I guess I'll skip a line each time. Okay, so now let's evaluate z sub 1. So it's still the cube roots, but the subscript is going to go between 0 and 2. So we still have the cube root of 27, but now we're going to have cosine of 0 over n, which we know to be 3, plus 2 pi over n, which we know to be 3. Let me put that. But now the subscript is 1, so my k for this problem is 1. Okay. Pardon me. Okay. So plus I times sine of 0 over n plus 2 pi over n times k, where n in this case is 3. The subscript for this root is 1. Okay, so the cube root of 27 is 3. So at least we've got that down. So it looks like the first term in each argument is 0, but the second term is 2 pi over 3. So this becomes cosine of 2 pi over 3 plus I times sine of 2 pi over 3. Okay, so that's 120 degrees if we care to. We can write this cosine of 120 is negative 1/2. And sine of 120 is root 3 over 2 positive times I, if we care to do that. So that would be the second cube root, of which there will be 3. So we have only one more cube root to get to. So let's call that one dark purple, I suppose. So z sub 2. So notice the subscript is always going to end at 1 less than the number of roots. So hence the k going between 0 and n minus 1. Actually, we will still have 3 roots, but the subscripts start at 0 and end at 2 for this guy. So this is going to be the cube root of 27 again. But now, inside the bracket, I'm going to have cosine of 0 over n plus 2 pi over n, where n in this case is 3. And now the subscript for this last guy is 2. plus I times sine of the same thing. So sine of 0 over n plus 2 pi over n, where n in this case is 3. And the subscript for this root is 2. Okay, yeah, I kind of thought I put a dot there. Okay, so the cube root of 27 is 3. The first term inside the argument goes to 0, so it looks like I'll have cosine of 4 pi over 3 plus I times sine of 4 pi over 3. So these are the 3 cubed roots of 27. And where is 4 pi over 3? That's in quadrant 3. So each of sine and cosine will be negative. So let's see, the 60-degree reference angle in quadrant 3 will be negative 1/2 and minus root 3 over 2 times I. Okay, so let's recap. What did we have? We had z sub 0 was, oh, wrong color. Sorry, it is this darker blue. So z sub 0 was just 3. Oops. Along 1 plus 0I. Z sub 1 was 3 times, let's do negative 1/2 plus root 3 over 2 times I. Maybe I should have left myself a space in between. And in fact, I think I'm going to write these in trigonometric form, just so you see where I'm going with this. So that was 2 pi over 3, so cosine 2 pi over 3 plus I times sine of 2 pi over 3. And last but not least, we had that z sub 2, the third complex cube root, was 3 times cosine of 4 pi over 3 plus I times sine of 4 pi over 3. Okay, so what I'd like to do with these 3 results is the following. So I'm going to consider a circle of radius 3. Let's see, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Let's see if I can draw a circle of radius 3 or not. Hopefully I can. Yeah, almost. Okay. Okay, that looks good enough. Okay, so my first root, z sub 0, was at 3. So that's a real number. That's on the real number line. So this is z sub 0. Okay, my second root, z sub 1, was at 120 degrees. So negative 1/2. So it's about here-ish. Oh, sorry, this is the IY axis, rather. Not the y-axis, because we are in complex plane. So IY. So here is my z sub 1 right up here. And my final root was, actually, do you know what? Let me make this a bit better. Okay, so this is the IY axis. Okay, if I were to distribute that 3, it would be about here. That's better. That looks better. So z sub 1 there. And finally, my third root, which is z sub 2. Yeah, getting my, is going to be at 4 pi over 3. So notice how these roots are distributed along the circle. It's like they're distributed evenly around the circle. So that's interesting to note. There's 3 roots, and we're dividing the circle into 3 parts. We should get 120 degrees. Okay, so now let's consider another. This is a long process, I know. Let's say for number 2, let's have the complex fourth roots. So the 4 complex fourth roots. Complex fourth roots. So in this case, n is 4 fourth roots of z being equal to, let's see, what shall we do? 8 minus 8 root 3 times I. Okay, so what color shall I use? Yeah, I'll use green for this one. So z is 8 minus 8 root 3 times I. So if I factor out a 16, what I'll get is 1/2. Actually, let me skip a step. Get 1/2 minus root 3 over 2 times I. So at what angle is cosine positive 1/2? And sine is negative root 3 over 2, and that would be at a negative pi over 3, otherwise known as 5 pi over 3. So this is cosine of 5 pi over 3 plus I times sine of 5 pi over 3. Okay, so let's note that n in this case, n is 4. Okay, so first we want to start off with z sub 0. So this is going to be the 4th root. And maybe I'll just, yeah, I should do it here. The 4th root of 16 times cosine of my angle, 5 pi over 3 divided by n, which is 4, plus 2 pi divided by n, which is 4, times this first subscript is 0, plus I times sine of that same thing, so 5 pi over 3 divided by n, which in this case is 4, plus 2 pi over n, which in this case is 4, times the subscript for this first guy, which is 0. Okay, so the second term is 0 in each of these, so the 4th root of 16 is 2. This just becomes cosine of 5 pi over 12 plus I times sine of 5 pi over 12. Okay, so if it were pi over 6, that would be a 30-degree reference angle. So pi over 12 is 15 degrees. 5 times 15 is going to be 10 times 5, which is 50, and 5 times 5, which is 25. So we note that 5 pi over 12 is 75 degrees, right? Just off to the side, we have that in the back of our head. Okay, what should I do now? Let's do z sub 1. Okay, so this is once again going to be the 4th root of 16 times cosine of 5 pi over 3 divided by n plus 2 pi divided by n, where n in this case is 4. And the subscript in this case is 1 plus I times sine of that same argument. So 5 pi over 3 divided by n plus 2 pi divided by n, where n is 4, because these are fourth roots we're looking for. And the subscript k in this time is 1. Okay, so the fourth root of 16 is 2. Let's see, we will have cosine of 5 pi over 12 plus 2 pi over 4. So in order to get a common denominator, namely 12, I would need to multiply 4 by 3. So this will give me 6 pi over 12 plus I times sine of the same sum, 5 pi over 12, plus 6 pi over 12. 5 plus 6 is 11 pi over 12. 11 pi over 12 plus I times sine of 11 pi over 12. Okay, and we'll note here, once again, that 11 pi over 12 is 11 times 15. So 10 times 11 is 110, and 5 times 11 is 55. So 110 plus 55 should be what, 165 degrees? That is, I'm 15 degrees shy of pi, which I should be, because pi would be 12 pi over 12, right? Okay, so now let's look at z sub 2, the third complex fourth root here. So 2, why do I can't speak and write at the same time. Z sub 2 is the third root. So what we're going to get then is the fourth root of 16, once again, times the quantity, cosine of 5 pi over 3 divided by the n, which in this case is 4, plus 2 pi divided by n, and the subscript for this term is 2, plus I times sine of the same 5 pi over 3 divided by 4. If only there was an easier way to do this. Plus 2 pi divided by 4, I wonder what that is, times 2, because the subscript here is 2. Okay, so the fourth root of 16 is 2, and this becomes cosine of 5 pi over 12 plus 4 pi over 4, but I want to write that as pi is going to be 12 pi over 12, right? 12 pi over 12 plus I times sine of 5 pi over 12 plus 12 pi over 12. So that gives us 17 pi over 12. So this is cosine of 17 pi over 12 plus I times sine of 17. Let me make that 17 better. 17 pi over 12. Okay. So where is 17 pi over 12? 17 pi over 12. Well, that's 5 pi over 12, or 75 degrees more than 180. So if I were to add 75 to 180, 20 of the 75 gets me to 200. So I have 55 left over, so that should be 255 degrees. Okay, finally, the last z sub 3, which is the fourth complex root, so z sub 3 is going to be the fourth root of 16 times cosine of the quantity 5 pi over 3 divided by n, which in this case is 4, plus 2 pi divided by n, And the subscript for this guy is 3 times 3. Make that 3 a bit better. Plus I times sine of the same argument. So this will be 5 pi over 3 divided by n plus 2 pi divided by n. And this n is the fourth root. And the subscript for this root is 3. Okay, I think we're almost there. So this becomes 2 times cosine of 5 pi over 12 plus 6 pi over 4. So if I wanted to get a common denominator, I would need to multiply top and bottom by 3. So 6 times 3 is 18 pi over 12 plus I times sine of 5 pi over 12 plus 18 pi over 12. Okay, so what is 5 and 18? It's 23. So cosine of 23 pi over 12. So I'm 1 pi over 12 shy of being full circle. So I times sine of 23 pi over 12. So I'm 1 pi over 12 shy of 360. So what that means is that, what color should I use? Use light pink. 23 pi over 12. 23 pi over 12. What's 360 minus 15? Well, that's going to be 345. So 345 degrees. Okay, holy free holy. Let's recap what we have here. So we have z sub 0 in that green. So we have z sub 0 was given as 2 times, I'm going to actually write this the ugly way, cosine times I sine of, what angle was that? It was 75 degrees or 5 pi over 12. 5 pi over 12. What color did I use for z sub 2? Or sorry, z sub 1. So z sub 1 is 2 cosine times I sine of 165, which is 11 pi over 12. What is z sub 2? Z sub 2 was this ugly one. So z sub 2 is going to be 2 cosine plus I sine of, what angle was it? 255, 17 pi over 12. 17 pi over 12. And finally, the last fourth root. These are the fourth roots. Z sub 3 is 2 cosine plus I sine of 23 pi over 12. Okay, so let's bring these all together and see what we get when we plot them. My guess is they're going to be, so we're on a circle of radius 2 in the XIY plane. XIY, this is a complex plane. Circle of radius 2. Oh, if I can draw it. Oh, almost. I can almost do it. Okay, there we go. Okay, so the first z naught was at 5 pi over 12 or 75 rather, degrees. So 75 degrees approximately here. So this is z sub 0. Z1 was at 165 degrees. So that's approximately here. So z sub 1. Oh, that's a terrible z. Let me write that a bit better. Z sub 1. Okay, z sub 2 is 17 pi over 12, which was 255 degrees. That's about here. So z sub 2, and finally, z sub 3 was at 345. So it looks like these 4 roots are evenly spaced in a circle. So basically I could do a divide 360 degrees by 4 to get their spacing. They're evenly spaced. Okay. So let's use that fact to simplify the next and final example for this section. Did I do a third example? Yes, I did. Okay. Let's do number 3. Let's find the complex, or the 5 rather, the 5 complex fifth roots. So the 5 complex fifth roots, let me write it out in English as I did before, fifth roots of, let's have z, in this case, b. Yeah, I guess I'll 243? Is that? I already did. No, I already did a radius of 3, I believe. Did I do a radius of 3 for this circle? No, a radius of 4. Okay, so let's have it be 243 times I. Okay, so let's look at z. What is z? So z is 243 times I. So I could write that as 243 times 0 plus I. So where is cosine 0 and sine 1? Well, that's going to be at pi over 2. So I claim that this is cosine pi over 2 plus I times sine of pi over 2. Okay. And what is n in this case? N is 5, right? So all I really need to do is find my first root, z sub 0. So actually, what color should I use? So I claim that z sub 0 will be the fifth root. Am I using? Oh, I'm using, these colors are too similar. Let me use a different color for that. Let's use this brown, even though I hate brown. So z sub 0 will be equal to the fifth root of 243 times cosine of pi over 2 divided by n, which in this case is 5, plus 2 pi divided by n, which in this case is 5, times the first subscript, which is 0, plus I times sine of the same ugly argument, pi over 2 divided by 5, plus 2 pi divided by n, which is 5, times the first subscript, which in this case is 0. Okay, so what do we get? We get the fifth root of 243 is 2. And this becomes cosine of pi over 10 plus I sine of pi over 10. Okay, where pi over 10 is 18 degrees. So pi over 10 is 18 degrees. Okay, so let's note, I'm looking for the fifth roots, right? So 2 pi divided by 5 is going to be 360 divided by 5 is 72 degrees. So all I need to do is add 2 pi over 5 or 72 degrees to each root. So hence, z sub 1 will be 2 cosine of 18 plus 72, so 2 pi over 5 is 4 pi over 10. So this will be pi over 10 plus, yeah, I'm going to do it the ugly way. First, copy, paste, 2 pi over 5 times 1. No, do you know what? Let me make life easier. Let's not go through all of this. Let's make our life easier. So z1 will be 2 cosine plus I sine of 18 degrees plus 72. So 18 degrees plus 72. There's no need for me to make it more miserable than it is, which is 90. So that's 2, right? Cosine plus I sine of pi over 2. Or 90 degrees. Okay, so z sub 2 will be 2 cosine plus I sine of 90 degrees, or pi over 2. 90 degrees. So this is, oh shoot, wrong color. Always using the wrong color. What color was that? That was this color. So this is 2 cosine plus I sine of 90 degrees. So I'm going to say 90 degrees here plus 72. Okay, so 90 plus 72 will be 2 cosine plus I sine of 162 degrees. Yeah, I don't. So z sub 3, the fourth of the 5 roots, is going to be 2 cosine times I sine of 162 degrees plus 72. So I just keep on adding 72 each time. Okay, so let's figure this out. 2 cosine plus I sine. So 162 plus 72. 6 and 7 is 13. So 160 plus 70 will be 230. And there's 4 extra, so 234 degrees. And finally, what color should I use? I guess pink. So z sub 4, the fifth of these roots, will be 2 cosine plus I sine of 234 plus 72 degrees. Okay, so what do we get? This will be 2 cosine plus I sine of 234. So 23 plus 7 would be 300. Plus an extra 6, so 306 degrees. Okay, so which ones do I have? So z naught, let's look at these recap, which was this in this ugly brown. So z naught was 2 cosine plus I sine of 18 degrees. Z sub 1 was 2 cosine plus I sine of 90 degrees. Am I adding okay? Hopefully I'm adding okay. 4, 6, 2. Yeah, addition might not be my strong suit. I don't have a calculator here. So z sub 2 was 2 cosine plus I sine of 162. Okay. Let's see. So z sub 3 was 2 cosine plus I sine of 234 degrees. Hopefully that was 72, right? 16 plus 7 would be 23. Yeah. Okay, it seems to be okay. Hopefully my math is okay. And z sub 4 is 2 cosine plus I sine of 306. That's what I keep on getting if I add 72. So hopefully these, when spread about a circle of radius 2. So let's look at the x and iy planes. Oh, fifth root of 243 is not 2. Oh my goodness. Wow, I must be too tired. I'm an idiot. I changed it from 2 and then I forgot to change it in my head. Why? See, you should never listen to me. Do as I say, or not as I do, or do as I don't do. I don't know. Okay. The radius is 3, guys, because I changed it before I began, and I forgot to change it in my head. Radius is 3. Why was that bugging me? And I didn't realize it till now. Okay. 3. Okay, got it. Much better. The radius is 3, so we're on a circle of radius 3. I was so concerned with the angles, couldn't do the easy part. Okay. Now maybe I could start this off a bit better. Let's see if I get this right. So I'm now on a circle not of radius 2, but a circle of radius 3. Okay. Modulus. Okay. Where was I? Circle of radius 3. So let's make this a bit bigger then. Okay, let's see. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, let's draw our circle of radius 3. Something like this. Okay, and now, so Z naught, the first Z was this color brown. So it was at 18 degrees about here. So this is Z sub 0, the first complex fifth root. The second complex fifth root was at 90 degrees. This is Z sub 1. The third complex fifth root was at 162 degrees. Z sub 2. The fourth complex fifth root was at 234 degrees. Z sub 3. And the fifth complex fifth root at 306 degrees. So Z sub 4. So notice the 5 fifth roots are spread in a perfect pentagram. Okay, so I'm still not done with this section, but I will see you in the next part of 8.3.